The transit of Venus is one of the rarest and most significant astronomical events observed from Earth. This celestial phenomenon occurs when Venus passes directly between the Earth and the Sun, appearing as a small black dot moving across the solar disk. These transits occur in pairs, separated by 8 years, but each pair is separated by over a century, making them once-in-a-lifetime events for astronomers and historians alike. Throughout history, the transit of Venus has played a crucial role in advancing our understanding of the cosmos, shaping scientific thought, and influencing global exploration. The first recorded observations of the transit of Venus date back to the 17th century, though earlier astronomers had speculated about its occurrence. In the early 1600s, the German astronomer Johannes Kepler predicted that transits of Venus and Mercury would take place based on his laws of planetary motion. However, Kepler himself did not live to witness the transit of Venus, which he had predicted for the year 1631. Kepler's predictions were based on heliocentric theory, which was still a matter of debate at the time. Although he was unable to directly observe the transit, his calculations laid the foundation for future astronomers to refine their methods. Unfortunately, the transit of 1631 was not visible from most of Europe, and no confirmed observations were made. However, Kepler's work inspired further study into planetary transits, leading to the momentous discoveries of later centuries. The first successful observation of a transit of Venus was made by English astronomer Jeremiah Horrocks on December 4, 1639. Horrocks, a self-taught astronomer, refined Kepler's calculations and determined that a transit would be visible from England. Along with his friend William Crabtree, he made careful observations, recording the movement of Venus across the Sun using a simple telescope and projection technique. Horrocks' observations were groundbreaking because they provided the first detailed records of a planetary transit. His work helped validate Kepler's theories and encouraged further study of planetary motion. Tragically, Horrocks died at a young age, but his contributions laid the groundwork for future astronomical research and exploration. The transits of Venus in 1761 and 1769 were pivotal events in the history of astronomy. Scientists recognized that these transits provided a unique opportunity to measure the astronomical unit, AU, the average distance between the Earth and the Sun. This distance was crucial for understanding the scale of the solar system and improving celestial navigation. One of the most significant figures involved in these transits was Edmund Halley, best known for his work on comets. In the early 18th century, Halley proposed that by observing the transit of Venus from multiple locations across the globe, astronomers could use the principles of parallax to calculate the Earth-Sun distance. His call to action inspired international expeditions to observe the 1761 and 1769 transits. The transits of 1761 and 1769 marked one of the first large-scale international scientific collaborations. European nations, despite political tensions, dispatched astronomers to remote locations around the world to gather data. Notable expeditions included Guillaume Le Gentil from France, who attempted to observe both transits, but faced misfortunes, including missing the 1761 transit due to bad weather and arriving too late for the 1769 event. Mikhail Lomonosov from Russia observed the 1761 transit and provided evidence of Venus having an atmosphere. James Cook from Britain traveled to Tahiti on the HMS Endeavour to observe the 1769 transit, contributing to crucial astronomical calculations. Despite various challenges, including wars, extreme weather, and long voyages, astronomers successfully recorded transit timings, leading to the most accurate calculations of the astronomical unit at the time. These efforts demonstrated the power of scientific cooperation and set the stage for modern space exploration. The next pair of transits in 1874 and 1882 took place in a period of rapid technological advancement. Photography, spectroscopy, and improved telescopes enabled astronomers to capture more precise data than ever before. Expeditions were organized on a grand scale, with teams sent to diverse locations such as South Africa, Australia, and remote Pacific islands. The United States Naval Observatory played a key role in organizing these observations, and astronomers were able to refine distance calculations further. These transits also captured public imagination, with illustrations and reports widely published in newspapers. By this time, the concept of an interconnected world participating in global scientific endeavors was becoming more prominent, and the transits of Venus played a role in shaping this mindset. After the 1882 transit, astronomers had to wait until the 21st century for the next occurrence. The transits of Venus in 2004 and 2012 were the first to be observed with modern digital technology, space telescopes, and global media coverage. With spacecraft like the Hubble Space Telescope, astronomers used the transits to refine measurements of exoplanet detection techniques. By studying how Venus dimmed the sun's light, scientists applied similar methods to identify planets orbiting distant stars. These modern observations demonstrated how historical astronomy has influenced cutting-edge research in exoplanetary science. The 2012 transit was widely observed, with millions of people around the world viewing it through telescopes, live streams, and special events organized by space agencies like NASA and ESA. This event marked the last transit of Venus in our lifetimes, with the next one occurring in 2117. The transit of Venus has been one of the most historically significant astronomical events. It has played a central role in advancing our understanding of planetary motion, the scale of the solar system, and atmospheric studies. These transits have inspired generations of scientists, explorers, and ordinary people to look up at the sky and seek knowledge beyond our world. From the early predictions of Kepler to the global expeditions of the 18th and 19th centuries, and finally to the digital age of space telescopes, the transit of Venus continues to be a symbol of human curiosity and scientific collaboration. Although we will not witness another transit in our lifetimes, its historical legacy remains an enduring testament to our quest to understand the universe.